Welcome to this new episode of Neural Muse, the podcast about technology and artificial intelligence. Today, I want to share a vision that could redefine the future of large language models, or LLMs, by introducing the SEAL project, which stands for Self-Adapting LLMs. Large language models, as we know them today, have revolutionized our interaction with technology, showing remarkable capabilities in understanding and generating language. However, they are inherently static. Once pre-trained on vast amounts of data, they lack internal mechanisms to adapt their parameters in response to new tasks, knowledge, or examples on their own. This shortfall limits their ability to assimilate new information or refine novel reasoning skills, particularly without specific, abundant fine-tuning data. Imagine a human student who, rather than passively memorizing information, rewrites it into notes or diagrams to better understand and prepare for an exam. This process of assimilating, restructuring, and rewriting data is integral to human learning and contrasts starkly with the as-is approach, typical of current LLM training. SEAL aims to bridge this gap by enabling an LLM to self-adapt and continuously evolve, transforming or generating its own training data and learning procedure. At the core of SEAL's innovation is its ability to have the model generate its own self-edits, which are directives for updating its own weights. Unlike previous methods that depend on external adaptation modules or auxiliary networks, SEAL leverages the model's own generative capacity to parameterize and control its adaptation process. So how does it work? SEAL operates through two nested loops, a sort of meta-learning instance where the model learns to learn how to generate effective self-edits. The outer loop involves reinforcement learning, RL, where the model produces self-edits, natural language instructions to update its weights, which can restructure information, define optimization hyperparameters, or invoke tools for data augmentation and gradient-based updates. The outer loop uses RL to train the model to generate effective self-edits, with the updated model's performance serving as feedback to optimize this generation policy. A filtered behavior cloning approach, RESTM, ensures stable RL training by reinforcing only positively rewarding samples through supervised fine-tuning. The inner loop focuses on updates, where a generated self-edit is used to fine-tune the model's parameters via supervised fine-tuning and gradient descent. Techniques like low-rank adaptation, or LoRA, enable efficient updates even with limited data. In essence, SEAL allows LLMs to self-generate fine-tuning data and update directives, learning through RL how to produce self-edits that maximize the utility of synthetic data. SEAL has proven versatile in applications, from seamlessly integrating new factual knowledge into LLM weights for improved question answering, to enhancing few-shot learning in abstract reasoning tasks. While challenges like catastrophic forgetting and computational costs exist, the future potential is promising, allowing models to assimilate and generate new knowledge autonomously, continuing to improve even on rare or underrepresented topics without external supervision. SEAL could also enable dynamic agentic systems, adapting behavior with experience. It's a significant step towards more dynamic, autonomous AI that can learn in an ever-evolving world where data becomes a limited resource.